Welcome to day 21 of Western Civilization. Our focus today is going to examine the contributions of the scientific revolution towards the greater study of this unit, revolution. The notable locations and dates will be contained within this video. They are not on this slide, but they will be outlined clearly here in just a minute. Now, essentially, what is the scientific revolution? The scientific revolution is something that occurred between 1500 and around 1700 or so, where you had a lot of scientists, or as they referred to back then, natural philosophers, that developed a new way of looking at the world, where you see more of a greater movement to have tangible evidence to explain the unknown phenomena that exists naturally. Now, essentially what we're getting at is that scientists envisioned that the universe could be understood through mathematics and experimentation. And now, using this tangible evidence, they wanted to prove why heavenly bodies interact in such a way. So one of the things that they start with is examining the universe itself. Now, the generally kind of accepted philosophy on the structure of the universe at this time was more or less a geocentric model, meaning that the Earth was the center of the universe. However, with strict observations, it kind of leads way to the heliocentric model, meaning that the sun is the center of the universe. So looking at the geocentric, you can take a look here, and you and I, as modern scholars, understand that this is incorrect, but back then, this was generally accepted as truth. So you can see Earth, the sun, Mars, all right, basically any observable heavenly body as it relates to its movement around the Earth during the day, the night, and so on and so forth. Eventually, it's going to give way to this, which is the heliocentric model, the sun being the center. And you can take a look at the planets, all right, and so on and so forth that have been added throughout time. Now, what this is this compares the geocentric model and the heliocentric model. And what you can see here by looking at these is that in this model right here, everything is a perfect elliptical, all right? It travels just straight and everything is parallel and equidistant and so on and so forth around the Earth at the central focus of this. Now, if we look at the heliocentric model here, you can see that there's a little variation in the orbits around the sun. So what happens with this new examination? It rejects a lot of classical Greek and Roman beliefs that were widely accepted. And eventually, the scientific revolution is going to enact a philosophy of really challenging traditional norms and values that eventually it's going to be used not just for science, but it's also going to be used to overhaul moral, social, and political thought by applying scientific reasoning. Additionally, it's going to weaken the influence of the church, and it's going to encourage more secular or non-religious values. Now, European astronomers based their understanding of the universe based on Greek scholar Ptolemy. And if this video will play here, I want to show you what it looks like. It's about 2 minutes long, and if I have to cut it off, I will. But it's going to show you essentially what the Ptolemaic model is and how we have a motionless Earth that's surrounded by different heavenly bodies. So as you can see here, obviously this is the sun orbiting around what will be Earth. These are just some different ideas about the path the sun takes throughout its orbit around the Earth. And so you can watch this a little bit more. The video is contained within the notes itself, and it goes on for about another minute or so. Now, the flaws of the classical model is that the planets often followed regular patterns, which is all right, that's good. And so it kind of supports a geocentric, Earth-centered model. However, sometimes the planets slowed down, sometimes they stopped, and sometimes they reversed directions completely. So this kind of throws that idea out the window, if you will. So along comes a guy, Nicholas Copernicus, and he's a Polish astronomer, and he wrote a book called On the Revolutions of Heavenly Spheres. That was published in 1543, and he argued that the sun, not the earth, is the center of the universe. So I want to show you the different models between the Ptolemaic and the Copernican model. So if you take a look here, feel free to slow this down, stop it, do whatever you need to do. But this is going to show basically the motion and the pattern of different heavenly bodies with the Earth at the center of the universe. So you can see where different bodies like this would slow down and stuff like that. Now if we look at more of the Copernican model, what you and I know as the model that we assume and follow and can prove today, this is what the path of the bodies look like. You can see the difference here between different heavenly bodies as they orbit the sun, excuse me. So the impact of the Copernican revolution is that the sun-centered heliocentric theory harmonized much better with observable data. Copernicus's ideas challenged a lot of scientific and religious ideas, including the Earth was just another planet. Human beings were not the central part of the cosmos, and the idea that humans may not be as divine as religious leaders thought. In addition, it kind of leads to this idea that there could be a possibilities of other populated worlds. So you can see how these ideas are extremely revolutionary during this period in history. Johannes Kepler, he's a German astronomer. He illustrated that the universe is not concentric. Planets evolve in elliptical orbits. Galileo Galilei, he was an Italian astronomer, and he took a recently developed instrument and turned it skyward. And so what that's going to be is the telescope. And he found that the cosmos was not a series of perfect bodies. He identified sunspots, moon mountains, 4 moons of Jupiter, and so on and so forth. You can take a look here at some of his drawings, the sunspots on the left, all right, and some of the moon surface on the right here. Isaac Newton was an English mathematician, and he wrote something called the Mathematical Principles of Philosophy in 1687, which united the universe and the Earth together. And so what he did is he was able to kind of connect these two overlapping conundrums and create kind of universal laws. And essentially what he decided or created was universal gravitation regulates the motions of bodies throughout the universe. And he had 3 primary laws within this. Number 1, that objects stay in motion unless acted upon. 2, acceleration is produced when a force acts upon a mass. And 3rd, every action has an equal and opposite reaction. If you're a visual learner, here's kind of what these 3 laws, Newton's laws, look like if they were illustrated. So feel free to pause this at any time and go back, check out the video to connect these 3 laws with the graphics. Now, Newton's laws allowed him to create a parallel between astronomy and mechanics. Newton symbolized the scientific revolution, for the most part. Many other sciences tested theories against direct observation and mathematical formulas. And this becomes a very dangerous change in thought. In fact, one of the culminations of this is something called the Roman Inquisition in the 1600s, where the Roman Catholic Church prosecuted individuals who committed offenses relating to heresy. They renounced their ideas, they censored their publications, and they excommunicated a lot of these scientists. So their findings and their impact wasn't received very well at all. Tomorrow what we'll do is we'll take a look at how the scientific ideologies change a lot of the moral and social aspects of the age as well. And so we're going to see a lot of people that start to question traditional norms and values, and how that's going to affect and influence the development and transition of society from more of a medieval or elementary to more of one that needs tangible evidence and data to progress. In addition, before you close this out and work on your DBQ, please note that I have published a reading on the website as well, and I want you to check that out and read The Age of Science. Thanks for tuning in.